In this video, we're going to do an example with a piecewise function. So this is example 4, continuing the numbering of examples from the previous videos. So g of x equals this piecewise function that we have here. And in part A, I want to find g evaluated at these 3 different values. Okay, so first, let's do g of -3. So to find g of -3, so I'm plugging in the x value -3. Which of these pieces is x equals -3 in? Is it in the top piece, the middle piece, or the bottom piece? Well, -3 lies in this interval. It's between -3 and 2, so this lies in the top piece. That's how I know that I need to plug -3 in for the x in this top piece. So if I do that, I get that negative that's in front, and then I have something squared, so I'll have -3 squared. And -3 squared, that's +9, and then the negative in front of it makes it -9. All right, so next let's do g of 2. So when I plug 2 into my function, which of these pieces does 2 correspond to? So 2 is in this bottom piece, because that's in the interval between 1 to 4. So if I plug 2 in for that x, I'll get 1 over 2. And then finally, if we do g of -1, I'm plugging that in for the x. -1 lies in this middle interval. It's going to be in between -2 and +1. So plugging in -1 into there, I'll get the absolute value of -1, which is 1. Okay, so that's how I evaluate a piecewise function at certain values like this. All right, so part B of this example is now I want to sketch the graph of this piecewise function. So my piecewise function has 3 pieces to it. It's got this -x² piece, it's got this absolute value piece, and the 1 over x piece. So I'm going to begin by remembering what do the graphs of those 3 functions look like. So let's sketch the graphs of those 3 pieces sort of individually. So let me draw an xy axes for each of these and draw each of their respective graphs. So some xy axes. So -x², that's an upside down parabola. So an upside down parabola has its vertex at the origin. And we're interested in the part of that lies on this interval from -3 to -2. In fact, let me zoom out a little bit so I can see this whole thing a bit better. So I'm interested in the part of this parabola that lies between those 2 x values. So let's say that this is where -2 is, and this is where -3 is. So where -3 is, x is allowed to be equal to -3 for that piece. So I put a closed circle there because I'm allowed to reach it. But at -2 for that piece, there's no equal sign on this inequality. So because of that, I put an open circle. So that means x doesn't ever reach -2 for that piece. Okay, and the part of the graph I'm going to keep is just this part that's in between those 2 x values. So the next function is absolute value of x, and that graph has this V shape. So that's my absolute value graph function. But I just want the part of that that's between x is -2 and x is +1. So -2 is somewhere here, and then 1 would be somewhere here, not as far as -2, but out to the right. Okay, and at -2, I do have an equal sign, so I put a closed circle. I am allowed to reach that point. At 1, there's no equal sign, so I put an open circle. I'm not allowed to reach it. And x is allowed to be anything between those 2 values, so I shade in this middle part. That's the part of my graph I'm going to keep. Okay, so let me also label some of these y values. So this is -2, the y value would be +2. This is 1, 1. On the previous graph, this would have been -3, -9. This would be -2, -4. All right, so we have those. All right, so I still have to draw the graph of 1 over x. That's a hyperbola. So 1 over x's graph looks something like this. And there's another part to it over here in the 3rd quadrant. And I just want the part of the graph that is between where x is 1 and where x is 4. So when x is 1 and where x is 4, When x is 1, there is an equal sign, which means I do include that point, so I put a closed circle. When x is 4, same thing. There's an equal sign, so I include that point and I put a closed circle. And I shade in all those x values between where 1 is and where 4 is, that part of the graph. So now I need to make sort of one combined graph where I take these 3 individual pieces and I put them all together. Okay, so I've given myself a little bit more room here and just copied down those 3 graphs that we have so far. So I'm going to make one combined graph. So let me put some tick marks. I'll go 1, 2, 3, 4. So this is 1. And then -1, 2, 3, 4. Okay, so I'm going to start to draw this. So this first, I'm going to draw this parabola portion. So this parabola portion, I have an open circle here. And then it keeps curving down. And then I have a closed circle here. This is -3, -9. This is -2, -4. And then the next part, so I'm going to have this part of the absolute value graph. Let's put that in a different color. So when x is -2, the y value is +2. So somewhere here-ish, maybe. No, +2. And then I draw the V shape, but I only go until I reach x is 1. And then I stop at that y value, at that point, and I put an open circle there. So this point is 1, 1. That other point was -2, 2. All right. And then finally, I need one more color. And I have to draw this part of this hyperbola. So the hyperbola starts with a closed circle at 1, 1. So that means that closed circle at 1, 1, that's going to fill in this open circle that I had. It's going to fill in this open circle at 1, 1. So that can happen. And then I keep drawing this part of this hyperbola curving downwards like this until I reach, and I had a closed circle here at 4, 1/4. And that's the graph of my piecewise function. So that is my piecewise functions graph. All right, so at this point we have done our last main goal for this section. We have looked at an example of a piecewise function and expressed and analyzed it.